Assalamualaikum warahmatullahi wabarakatuh. Now we gonna discuss about the force systems, which is the force system is an action of one body on another, so it will tend to any movement of a rigid body. And in real life, you can also see in this case. Here is the example on a real life situation that if you have any bracket, if we have any cable tension, and will be there is the angle, so we have the cable tension which is the has the magnitude and also the direction, and the P will revert to the F the forces, so it is the factor quantities, and also we have the theta. Maybe it's not as easy as that, so you have to change this one to the side view, and it will make you easier to find the P, the direction and the magnitude of P, and also to find the theta or the angle of theta. So what is really give the effect on the bracket? The effect on the bracket on this case will revert to the P. It also means that revert to the magnitude, to the direction, and also to the theta, and also it will revert to the point of application. If you change the point of application, or you change the P, and also if you change the magnitude of the angle of theta, it will be give the different effect to the bracket. And the principle of transmissibility, which is state that a force that applied at any point on its given line of action without altering the resultant effect of the forces to the rigid body on which it acts. So if we have a force applied at any point, whether they are applied in a B or they are applied in A point, as long as they are given in line of action, so they are in one line of action, it won't give the different effect of the force of external or the external force of this rigid body, so it will give the same resultant of the force. But if you change the line of action, for example, if you have the A point here and you move the B point here, it will give the different resultant force because they are not in line of action. So it's different with the previous force system, that it will revert to the direction, to the magnitude, and please keep attention that in a transmissibility, it will depend on the line of action. It's not revert to the point of action. So this is different with the forces in the previously in the transmissibility. It won't change any the resultant force as long as you are in the line of action, in the same line of action. And in the concurrent forces, it will call the concurrence if you have two or more forces and they are the line of action intersect at a point. For example, I have the F1 here and I also have the F2 here, and they intersect in one point, in a point. So it will called as a concurrent forces, which is using the concurrent forces we can find the resultant by using the parallelogram law, and also we can use the triangle law, and the resultant based on this case it will revert to the F1 plus F2. In this case they are intersect at a point. So what if in the case we have two forces that it is applied in a same plane, but they were applied in a different point? For example, I have the F1 here and the F2 here. They were applied in a different point. I'm going to say that it's maybe it's a B point and here is C point. So what we have to do to find the resultant of this one? So to get the resultant of this one, we back to the principle of transmissibility, that is mentioned that we can move as long as they were in line of action. So we move this force in a line of action until we can find the intersection between the F1 and F2. So they will be intersect at a point, and same as the previous, we can use the parallelogram and also the triangle to get the resultant of this one. It is the parallelogram example, and here is the example of the triangle law. And there is a different way to get the resultant, but please avoid this way because we gonna find a mistake on the line of action of the resultant. It will give or preserve the correct magnitude and direction, but it will we will get the mistake of the line of action. Why? Because the line of action here, it doesn't pass through the intersection point, because you have to pass the intersection point. The special case of the factor addition is here. I'm going to explain first that I have two forces. First one is the F1, the second one is the F2. These forces were parallel. These forces were parallel, so we are getting difficulties. So for example, like this one, we have the F1 here and the F2 here. It is the parallel. So how to get the resultant of this force? The firstly, you have to adding the force, which is in this case the F and the minus F. But please remember that it have to fulfill the requirement of the force, that this force have to be equal, and the second one, it have to be opposite, and the third one, it have to be collinear. In this case, it is equal, F1 and the minus 1 equal, and it is opposite. We can see that it is the positive and it is the negative. It's reverted to the direction, and the collinear, they are in the along one line of action. So after we get this, it will come back to the previous before system. We can get the resultant using the parallelogram or the triangle law. We will get the R1 and R2, where R1 was the resultant of F1 plus F, and R2 was the resultant of F2 plus minus F. After this, we can take the long way of the action of the line of action of R1 and R2, and the other side we will get the R by moving the line of R1 and R2 following the line of action of this one. We will get the new intersection here. Maybe we're gonna say that the D intersection. In D intersection, we will find the new resultant of R1 and R2. So the resultant of here is equal to the R1 plus R2. That's all for the force systems. Thank you. Assalamualaikum warahmatullahi wabarakatuh.